Okay, let's keep going with vectors. So the question was the idea of once again, vectors are journey. They're journeys. So if you see, let's keep going with vectors. Yeah, vectors are journeys. So if you see a diagram like this, let's call this R, let's call this S, and let's call this T. These are not this. This is a triangle, yes, but these are journeys. So R starts here and moves to the right. S starts down at the lower right, left, and moves to the upper left. T starts at the upper left and moves down to the lower right. So, but we can write each journey. So let's look at journey R. R starts here and ends here, right? So how do we go? Well, we can say that R is equal to T plus S. Here's the first journey, right? Here's the first journey, and then here's the second journey. We got to the beginning and the end of R. Well, let's take that out, right? How about we write the journey of T? How about we write the journey of T? What is T? Well, T starts here and ends here, right? So let's see, my first journey is to go along R, but then I have to go along S, but S goes up, so I go the reverse of S. And those T is R plus the opposite of S. What about the journey of S? Okay, that's not difficult. S starts here and ends here. Well, let's see. How do I do S? Well, I go the opposite of T and then plus R. Or I can write it as R minus T. And that's the idea. It's about the vectors represent journeys, and we're going to see in a second they represent displacement. And so you can have some fun. That's basically, we can look at exercise 4. Let's go to the book. Let's go to the book. You have the book. We're going to go to exercise 14B3. Let's go to 14B3. Let's see. Where's 14B3? 14B3. And we have these fun exercises. So let's look at C. Let's look at C. And we can see that C is a quadrilateral. We have S. We have P. We have Q. And we have R, and you can pick any of these. You can pick any letter. So what was this? This was 14B3. You can pick any of these, and they ask you construct a vector equation for any letter. So I'm going to pick R. So R is equal to, well, where does R start, and how does it end? How do I get from the beginning to the end? Oh, I have to go around. Well, it's kind of interesting. First, I have to do negative Q, then I have to do negative P, then I have to do negative S, right? So I can write it a couple of ways. I can do, negative P, Q minus P minus S. Yeah, you can pick any letter. Let's pick another one. We can look at the exercises. And then you're asked to write these in terms of S. So for example, let's look at page 392. How about number 2? And let's take this really interesting diagram. This one's kind of cool. At the bottom, let's see, we have A, B, C, and D. Let's see, A, B, C, and D. We're told that vector AB, we're going to call it P. Vector DB, we're going to call it Q, okay? And vector DC, we're going to call it R, right? And we're asked to find the terms of P, Q, and R, AD. AD, how do I get from A to D? How do I get from A to D? Well, AD is equal to AB minus BD, right? So that's P minus Q. Kind of interesting, right? Let's show, what else are they asking? BC and AC. Let's move this over. Let's try another one. Let's try another one. How about, you know what? I should use a different pen. Let's see. BC and AC. BC. How do we go from B to C? Well, let's see. That will be BD plus DC. Well, BD is, well, DB is Q, so BD is negative Q plus DC, that's R. Or it can be written as R minus Q. But once again, these are the journeys to take me from, point to point. That's the idea. That's the idea. AC. AC, let's look at AC. Oh, let me clean the board a little bit. Yeah, this is really fascinating. Go through these slowly but surely. Take your time with these. Once again, this is math, it's not physics. So we're doing geometry. AC. What is AC? What is this? Let's see. We start here. What do you think? AC. Well, AC is AB plus BC. Let's see. Well, we found, so AC, let's see, AB was P. What was BC? R minus Q. P plus R. Yeah, that's AC. It's kind of interesting, right? Yeah, kind of interesting, right? So you get these interesting, and what we'll see is that we can use vectors to prove a lot of things. Kind of interesting. Please practice these problems. Let's move on. Geometrics into the next unit is scalar multiplication. Scalar multiplication. Please remember, this is a totally new topic. So we're just moving our way through, like, third grade, fourth grade, fifth grade. So you might say, well, this is ridiculous. This is easy. Yeah, you're building something from the ground up. This really is our first. This is our first IB post pre-calculus unit. This is our pre-calculus unit. Once again, you've never seen vectors before, so you're doing this from the ground up. So it may seem like obvious, like, yeah, these are arrows. Yeah, you're developing this from scratch. What is a scalar? Well, a scalar is just a quantity. It's just a quantity. So the idea is, if we have a vector, this is A, do you think is 2A? Well, 2A is one of these and another one of these. So this is the vector 2A. What do you think, like, 1/3 A looks like? Well, it's kind of like that. That's 1/3 A. Once again, all of these are in the same direction, but now we have multiples of it. You can see where this is going. What about negative numbers? Well, sorry. I'll go to school tomorrow. Let's see, what else? What other scalars are we interested in? We have the positives. 0 is obviously, 0A is obviously the 0 factor. Can we do negative factors? What do you think that means? What do you think? So once again, if A is this vector, what do you think, like, negative? Well, first of all, what is negative A? Well, the negative, the only thing it does is just the opposite direction. Right? And so you could technically have, like, negative 3A, which is 3 of these, but the opposite direction. That's the idea, and that's it. Once again, so if K, can you see over there? Yeah. If K is greater than 0, it's the same. So we have KA, and K is a scalar, and A is the vector. And if K is greater than 0, it's the same direction. And if K is less than 0, it's the opposite direction. And Yeah, practice these problems. Number exercise 14B4. Yeah, just go through these. Go through these exercises. I like number 5. Okay. Last thing I'll do for today. 14C, vectors in the plane. So this is kind of cool. So now we're getting it on graph paper. So we want to draw a vector, right? So the first thing is we're going to do a notation. Okay, and the notation is going to be x, y. This is not a fraction. This is vector notation. This tells us the change in x, and this tells us the change in y. So, once again, not a fraction. Not a fraction, not. So, the idea is if you see 2, 3, if you see 2, 3, and you look at like a piece of graph paper, you can start here. Here's the tail, and you go 1, 2, 1, 2, 3. That's a vector. But you know what? Vectors don't care where you start. So you know what? So this is vector 2, 3. I can start down here and go 2 to the right, 3 up. That's also 2, 3. Once again, vectors don't care where you start. They don't care. As long as it's 2 to the right and 3 up, all these vectors are equal. Let's do it over here. Here's, 1, 2, 1, 2, 3. That's also 2, 3. All of these vectors are 2, 3. And so, once again, it's, change of x is 2, change in y is 3. So what we're moving towards is I can do x, y. We're going to introduce the third dimension here. But today we're going to take it easy. So what I'd like you to do is, on a piece of graph paper on your own, what I do is, if I had you here, I would have you graph, the following vectors. The following vectors. You see that? Yeah. I'm going to ask you to graph 1, 5. I would ask you to graph, 3, 3. I would ask you to graph -2, 1. I'd ask you to graph 3, -4. I'd ask you to graph -5, -2. I'd ask you to graph 2, 0. I'd ask you to graph 0, 3. I'd ask you to graph -5, 0. And I'd ask you to graph 0, 1. And so why don't you take time to do that, and then I'll turn the video back on. Okay, let's see. So here's our graph. And let's imagine there's graph paper there. Obviously, there's not, but it's no big deal. So let's start with the first one, 1, 5. Well, I'm going to start here. 1 to the right. 1, 2, 3, 4, 5. Oh, this is 5. So this is the vector 1, 5. Could I have started it here? Yeah. It doesn't matter where you start. You just have to follow. That's 1 to the right, 5 up. What's the next vector? 3, 3. Let's start 3, 3 over here. Here's 3. 1, 2, 3. 1, 2, 3. This is the vector 3, 3. Once again, it doesn't matter where we start. Now you're kind of getting a sense that each of these vectors has a unique direction. And yeah, we're going to talk about that in a little bit. Let's go. And actually, you kind of see where the trigonometry comes in. You can kind of see how we can figure out the angle here. The slopes, the angles are a little different. You can use your trig to find that. -2, 1. Well, let's start -2, 1 over here. Well, this is 2 to the left, 1 up. -2, 1. And so this is interesting. This is now going like northwest, 2 to the left, 1 up. How about another one? How about 3, -4? Let's start here. Let's see, 1, 2, 3, 1, 2, 3, 4. This vector represents 3, negative 4. Look at all the different directions we have. Now we're getting a sense we can have magnitude. Because if you imagine these are right triangles, I can figure out the magnitude. This is 5, and I can figure out the angle using trigonometry, sine and cosine, or tangent even. What else? What's next? 5, negative 2. Let's see. Let's go over here. I don't even need a graph paper. I can just do right here. Negative 5. So I can start here. 1, 2, 3, 4, 5. 1, 2. Down 2. This vector could represent negative 5, negative 2. Let's try another one. Let me loosen that. Let me lose another. How about 2, 0? What direction is this? Well, let's start down here. Let's see, 2 to the right, 0 up and down. East is now represented by this vector. Go east 2 miles. Now we have a representation. Say, go east, go west. This is east. What's going on here? 3, 0. What's 3, 0? I'm sorry, 0, 3. Let's start here. 1, 2, 3. So once again, don't go left or right, just go straight down. Now we have something to represent south, right? Or you might say, hey, Mr. Adler, that's 270 degrees, right? I mean, think about this. Let all your trig flow into this. Let your trig flow into this unit. What are we doing next? Negative 5, 0. Well, this is negative 5, 0. Let's see, this was 0, 3. 0, 1. 0, 1 is simply 0, 1. So this is 1 unit. Now, so for those of you taking physics, that's 0, and what else? And so I want, first of all, let's see, what do I want to do? Yeah, the last thing I want to do is, so the idea is these are the journeys. These are the journeys you're going to take. So now I'm going to say, the idea is you're going to add these vectors, and these are the 2 journeys you're going to take, right? So I'm going to say your first journey is like 2, 3, and your next journey is 1, 7. Now, please pay attention. This is very difficult. Some kids get confused by this. I want you to understand. So I want you to see what I'm doing here. So the sum, right? Are you ready? This is very difficult. It's higher level math. You ready? And so this represents the displacement. So the idea is the first journey starts at here and goes 2, 3. This is the first. So this is like A plus B. So this is A, right? And let me change. I'm sorry. Let me change this to. No, 1, 7. This is fine. The next journey is 1, 1, 2. No, I'm sorry. Let's change that to negative 7. So this is negative 4. So it's 1. So this is B. Where does B start? It starts where A ends. 1 to the left. 1, 2, 3, 4, 5, 6, 7. So this was B. Okay, and then the displacement, this is the idea. The displacement here, this is A plus B, and this is 3 to the right, 4 down. And that's the idea of adding vectors. Once again, it's just one journey after the other. It doesn't matter where, once again, there's no place where it starts. You just say, what is this vector telling me? Oh, this vector is 2 to the right, 3 down. The second journey is 1 to the right, 7 down. And therefore, the displacement will be 3 to the right, 4 down. And that's the idea of vector addition. So I'll shut this lesson off. You're going to do everything in the book up to You know what? Let me just throw in something else so the question is, no, we're good. Excellent.